Good morning, everyone. Thank you for joining us today. So today we have Jesse Ives with us. He's the product manager at Finning, and he's going to do a little presentation all about rebuilds. Rebuilds are a hot topic right now as we see the kind of capital budgets, either shrinking this year or next year in the near future. And rebuilds are a very good option for you folks to help meet your equipment needs. So he's got a presentation, Rebuilding Your Equipment. When does it make sense? So on that note, I'll pass it over to Jesse Ives.
Great, thanks, Tyler. So yeah, thanks for the introduction. I look after a few different product lines here at Finning, engines, drivetrain, and rebuilds specifically. And so I've been with Finning for a little over 5 years at this point. A few different roles on my end. So a couple things we'll talk about today. Repair before failure. Going to talk about that as a bit of just a statement as to why it's important. Then we'll talk about some of the types of rebuilds, some updates from the Finning end, what we're working on and those sorts of things, and then some existing programs we have in market as well. So why do you repair before failure? Well, biggest part of that is you're really wanting to maximize your parts reuse. What we know is that a significant percentage of parts are actually designed to be reused, right? So when we look at major failures, nearly 90% are actually entirely preventable, right? So there's about a 10% chunk that happen. There's no way you can predict that they're happening. And so that's just cost of doing business is what that comes up as. But what we look at is failure costs are actually close to double and considerably more in some cases. So you really want to avoid that failure as much as you can. The other side of it, and part of why you see that doubling of costs, is actually because the high risk of contingent damage to other parts as well, right? So when you have a major failure, oftentimes it leads to other failures or other damage within other parts of the drivetrain or other parts of the machine as well. So we see a number of different reasons as to why customers may not repair before failure. They're going to wait to that failure mark. So I've highlighted the 4 most common that we see on our end. So first one, why fix it if it's not broken, right? Very, very common from our end. So it's going to fail at some point. Whether you get in front of it is a big deal, right? Because essentially it's a lot more to fix it after it's failed. Repairing early can actually save a ton of money down the road, right? It's that aggregating of effects as well going on there. The turnaround times, we see this as well, right? Every repair takes a little bit of time, right? But what we do know is that every failure or repair after failure often takes considerably longer on that side of things, right? So we want to make sure that we're getting to them before the failure occurs. It just accelerates any repair timelines that are necessary. Third one is one we see a lot, right? Especially as we look at Canada, we have, seasonal effects here, right? When it's snowing, you got to be working. When it's, it's summer, you're trying to maximize that season. We don't have as many working months necessarily here as some other places, right? So really, that production demand piece often comes up. We're too busy right now. What the answer to that would typically be is we will always see that, with a failure, if we have that your current production is going to suffer, right? So getting in front of it, we have solutions to help accelerate things on that end as well. And then the final one is we do see this from time to time. So operators aren't necessarily raising any red flags about machine problems. Often, operators might not be aware. So we might not be communicating, or they may not be communicating some of those potential issues that are coming up. They keep producing, keep working, right? Machine seems to be working just fine, but in reality, they're just not raising some of those red flags because they may not see them. Okay, so the next piece here would be really looking at some of these parts and specifically which parts we're looking to rebuild and repair as well. And sorry, I just got a bit of background noise, just going to mute real quick. Okay, so first point here, sorry about that, is looking at level 1 parts, right? And this is typically what a repair before failure looks like, right? So we're going to look at the engine and drivetrain and what those parts typically consist of when we're doing, a repair before failure. So level 1 parts, they are designed to wear and protect, mating parts, right? So really what your level 1 parts are is you want to sacrifice them, right? They're the fastest wearing parts. They're typically not reusable. you know, when you look at an engine, what you're looking at with those level 1 parts, you're going to look at rings, bearings, plates, some of the valves, exhaust valves, gaskets, and seals are the really common ones as well, right? As we shift gears and look at the drivetrain level 1 parts, really what you see here is, you know, some of the bearings, seals, gaskets, thrush washers within the machines. Those are those really big parts of the level 1 parts, right? Especially, you know, trying to preserve some of the next level of parts through the drivetrain and through the engine. That's what we're trying to do by sacrificing these parts. As we go to the next level of parts and how we look at these, we look at the engine, right? And level 2 parts, typically they wear at a much slower rate, right? They're designed with reusability in mind. Oftentimes when we look at level 2 parts, we want to get at least another life out of them. It's really important to keep track of that parts reuse. We're really trying to get as much out of them as we can. So when we look at an engine, what those level 2 parts consist of, again, pistons, some of the liners, valves, camshafts, bearings, turbo bearings, and seals, right? So some of those higher level parts that are going to cost a bit more if you have to replace them. And then when you look at that from a drivetrain perspective, again, probably no major surprises here, but some of those plates, discs, gears, and shafts, we're trying to reuse those, right? Especially for the first to second life of that machine, we really want to make sure we're saving as many of those level 2 parts as we can. That's part of the CAT promise, right? Is really making sure we're getting as much value out of it as possible. As we shift towards level 3, this is where the importance of, you know, some of that salvage and reuse and really repairing before failure really come into effect, right? We want level 3 parts to last the life of the machine. The replacement costs here are dramatic, right? If you have to replace some of the parts that are at that level 3, that's where you get into some of those really intense increases in price. So a lot of the time, replacement on these parts, it's due to catastrophic failure, right? So it's not doing that appropriate maintenance. It's not doing that appropriate repair before failure. You get into a catastrophic situation. As I mentioned at the, you know, the first slide, it's going to be double, triple the cost of repairing before failure. Obviously, because these parts, they're meant to last the life of the machine, right? So engine side of things, you're looking at blocks, you're looking at cylinder heads, cranks, some of the rods as well, right? Those are expected to last multiple lives and you want them to. Similarly, drivetrain side of things, cases, housings, some of the planet carriers, hubs, main shafts, those are the pieces we're looking to preserve in the drivetrain as well, right? Those should last multiple lives. Repairing before failure is an essential part of that. So when we look at this, just how it all maths out and ends up, right? That white line is going to be those level 1 parts. The red line is going to be the level 2 parts, and the blue line is going to be level 3. And so what you can see is there's basically an accelerated use of those over time, right? So level 1 really goes through these peaks and valleys. You kind of get, you know, an expected lifespan out of it. Level 2, they're supposed to last a little bit longer, right? That's the intention. They're supposed to last multiple lives. And then level 3, you can see really, you know, those more expensive pieces and parts of the machine, they really, you know, they're supposed to degrade very, very gradually to last multiple lives, right? What we see is oftentimes there's a critical failure or a catastrophic failure at the intersection of when these two level 1 and level 2 parts kind of coincide, right? So if we wait to do some of that major repair work up until that point, that's when you can have that catastrophic failure. From a finning perspective, the way we look at this is it's a bathtub curve, right? So when we start thinking about rebuilds and, you know, whether it's, you know, a new machine or after a rebuild as well, you're typically going to see things follow a very bathtub oriented curve. So there will be early hour failures, right? At the start of the bathtub here, we expect things to really, really flatten out, right? And then there's the upward swing of the bathtub curve as well, right? That's when you're starting to get into that accelerated wear. That's when you're seeing some of those level 1 and potentially level 2 parts start to fail, right? And that's where that risk of the catastrophic failure starts to enter in. So it's that point right there, which, you know, it's not as easy as looking at a chart and saying this is when we want to rebuild. We have some tools obviously in our tool set to help with this, right? We know what the benchmark of a machine should be. We know what the benchmarks of those components should be. Obviously we're able to look at oil sampling. We're able to look at some of the indicators as well, right? What is your machine telling you, right? Is your machine connected? And we have some of that information to say, hey, look, maybe it's potentially time for a rebuild, whether on a component or on a machine level. So you're really trying to tap into that optimal rebuild interval there. So when we look at this, this is a dozer. So this is for a D8, right? And I just like to highlight this because this is kind of what you look at for the cost of things, right? And there's a couple things I want to pull out of this. So hours at the bottom, really you've got some major decision points at about 10 and 18,000 hours, right? This is where you see, almost a rebuild or a repair before failure type consideration, right? And when we look at a machine like this, we're looking at that 10,000 hour, really repair before failure, right? Get in there. We're doing those gaskets, those seals, right? Some of those parts that are designed to wear and designed to degrade over time, right? And then as we get into that, 18,000 hour range specifically for this machine, that's really where we're looking to do some more comprehensive rebuild efforts, right? So repair before failure and then rebuild the machine as well, right? And we have these kind of schematics for all of the machines that are Caterpillar, right? So you look at this and you can see this line is starting to increase, right? And similarly here, it starts to slope up and then it flattens out. Basically, that flattening is, hey, we've gotten to it before the failure occurs. You've got a more predictable cost to your machine and to that asset, right? The challenge here is if you don't do some of those maintenance and repair before failure, you risk the catastrophic failure, and ultimately this line continues trending up, or even the curve becomes more exaggerated, right? So you can see the importance of getting to that repair before failure. When we look at the cost per hour, right, this is mapped out from the same piece. Really, these are those two decision points, 18 and 10,000 hours. You can see obviously higher costs, right? So you've got some larger engine pieces, drivetrain pieces, potentially undercarriage pieces because this is a dozer, right? And so basically you see those coming up significantly at the 10,000 hours. But interestingly, your cost per hour, it flattens right out. Right. And it's because you've gotten to that predictability within the asset, you're maximizing the value of that machine. Your cost per hour goes up slightly because you're getting to it repair before failure and then rebuilding, but it's predictable. You know exactly what's going to happen, or you have a pretty good idea anyways. So different machine here, we'll look at a 980H, right? And this is just a bit of an example as to, what we'd anticipate with a rebearing reseal on a transmission, getting to that before failure. This is more of a recondition effort is what I would say, right? So you're waiting almost until some of those level 2 parts have started to fail before you're doing anything. You're risking more, let's put it that way. And then there's the after failure situation, right? So you've waited, something on that machine grenaded, and ultimately you had that more catastrophic failure. And this example doesn't even look at the contingent damage. It looks specifically at the transmission and that failure. So almost certainly when that failure occurred, there'd be additional costs as well. But what we see is basically that cost per hour and what that breaks down to. It's lowest for the rebearing reseal effort. Getting into the recondition, again, it's still relatively low. It's about double what that rebear reseal would be. But then you get into the after failure state, which is the most expensive of the three. You're paying $369 an hour if you've waited to that point. And really, when we look at the payback, what it takes to pay back the extra 2,000 or 3,000 hours you've gotten out of that asset, it's a lot, right? It would take you running that asset for 30,000 hours to justify that decision, right? So it makes a lot of sense to get to things before that major failure occurs, really doing the before failure state. Okay, so we've gone through some of that. I want to talk a little bit about the types of rebuilds we have in territory. Certified rebuilds, we have a couple different aspects and components of that. Basically, the certification standard comes from Caterpillar. So machines are built to like new standards. The components can be as well at a fraction of the cost relative to new, right? And so what we're trying to do, and a big part of the CAT promise, is driving that extra life out of the machine. So the scopes are, pretty rigid. They're defined by Caterpillar, and they're basically saying, if we do, X, Y, and Z parts, we know that you're going to get another life out of this component or machine. And so when we look at those major categories, CMCRs, the first one, so we can certify components. So those are basically major component rebuilds. And when you talk about a major component, you're talking engine, transmission, torques, finals, differentials, axles. Those are typically what we define as the majors within Finning and Caterpillar. The next level up is a certified powertrain rebuild, which is, exactly what it sounds like. We're rebuilding the powertrain. Next category up from that is a CPT, Certified Powertrain Plus, or a Certified Powertrain and Hydraulics. And typically the plus applies to anything, maybe we're doing the cab. Typically the hydraulics are considered, maybe it's GT, undercarriage, some of those other elements as well. And then CCRs, which we don't see as many of in territory, but are essentially a complete rebuild, right? And so the entire machine is rebuilt, basically just the frame and some of the other pieces sticking around, and the machine receives a new serial number as a result. Any certified rebuild does qualify for, CAT's equipment protection plan, EPP, warranty, and other terms, right? So when you look at it, it's 1 year, 500 hours, all the way up to 5 year, 10,000 hours. And we've even seen some exceptions as well. So obviously a broader range there of terms to help provide that warranty on the back end of a rebuild. So what is a CCR? I'll spend only a minute here. Again, we don't see a ton of these in territory. They are done. They are quite an interesting piece here, right? So it's endorsed by CAT. It's basically on any given machine, you're looking at least 7,000 new parts. You're getting basically a like new appearance and performance, right? So to the untrained eye, it's going to look like a brand new asset, right? You're putting a new serial number on the asset. There's tax implications, obviously, to doing a CCR. It is treated the exact same as when you buy a machine and amortizing it that way. So you get a new pin. It's for all intents and purposes very close to a brand new machine. But typically what we see is it's about 80 to 90% of the cost of new. The more common category we see is the certified powertrain rebuilds, right? And so as I've talked about, within the powertrain, there's a bunch of the major components there, but basically you're talking about axles, differentials, engines, finals, radiators, torques, transmission. A bunch of those pieces are part of it. And then when you get to the plus piece, obviously looking beyond that CPT or certified powertrain, that's where those other pieces come in. So, are we doing any welding on the mainframe? Are we doing the hydraulics? Is there anything needed on the interior, right? That cab refresh. Exterior as well, some safety elements, hoses, wiring harnesses, tires, undercarriage, maybe we're reconditioning the bed, right? Those are all those elements that can come back in as plus pieces. And so there's also this other category, which is getting a lot of attention this year, and especially as we look at constrained budgets, right? So dealer rebuilds. Dealer rebuilds are basically defined by Finning instead of Caterpillar. And basically it's a number of the elements that would be included within a rebuild, but it's a bit scaled back scope. So I mentioned that CAT sets out those very specified scopes for certified rebuilds. Well, a dealer rebuild is defined by asset Finning, right? And so there are some things that on the Finning end of things, and even talking with our customers, we know it doesn't make sense to replace every time, right? Sometimes those scopes to be certified, we may feel they're too exacting, right? So you look at an electronic control module, an ECM, right? Sometimes those are going to get a bunch of extra life out of them, right? We don't necessarily need to replace it. Same with hoses, some of the sensors, solenoids, harnesses, etc., right? Even the batteries, right? We want to make sure we're maximizing life there. And if we feel like those things can last another life, great. Let's make sure they do, right? And because we're removing some of those parts from the scope, typically we see dealer rebuilds fall in that price point of anywhere from 40 to 75% of certified, right? So what that actually means is they're coming in at less than 50% of new almost all of the time. One of the cool things that came out this year is dealer rebuilds are actually now eligible for Caterpillar's equipment protection plan. So that same warranty piece I mentioned on the last slide, dealer rebuilds are now qualifying for this, right? A little bit different terms. It's a new process for CAT, so they are learning. But up to 3 years, 5,000 hours will be covered within the scope, and it can cover powertrain plus the powertrain or standalone engines and transmissions as we do work on those. There are some things as well, reman exchange pieces as well that we can do and still cover under this as well. One thing to note is if you're just doing an engine or a transmission, customers on your end, you can actually do the removal and install completed by yourself, provided we're doing the work on the engine or transmission itself, and you can still qualify for EPP. Biggest contingency there would be, if we're doing the removal and install, any contingent damage is covered, versus if you're doing it on your end, we don't cover the contingent damage just because we don't oversee the full process. And then finally, there is something else we have in territory, which is called our component assurance program, which is prorated coverage of the parts within, a component or powertrain rebuild. There's no additional cost to this component assurance, but we do ask that the assets are covered within a customer value agreement or a CVA to ensure that the appropriate interval and maintenance schedules are being followed. I won't go too into depth on what component assurance is today, but essentially you're getting prorated coverage as well if maybe you don't have warranty, or maybe you want to put it on top of warranty as well. So we look at a couple of the certified rebuilds here, right? I mean, these are some examples recently in territory. In fact, I think this one just finished, obviously a bigger machine, right? But you can see the dramatic difference in a machine once it's been rebuilt, right? It's visually stunning, and you can see it. And so the question we often get asked is, you know, what models can be rebuilt, and should all models be rebuilt? And the easy answer there is most models can be. Should all models be? The answer is no. And I'll say that right off the bat. There are some, you know, machines that, based on their size, it just doesn't make economic sense. Additionally, there are also some machines, you know, when we look at them, you know, based on the conditions they're operating on, you know, based on the wear and tear on them, based on, you know, maybe they're not at that point in their life, we're not going to make a recommendation saying this should be rebuilt if we don't truly believe it should be. Ultimately, when you look at this list though here, obviously there are a bunch of different machines here. There are very few assets that we can't rebuild. When we look at, you know, those certified rebuilds in the last year and what we've done, this is a bit of a snapshot. So you can see these are more specific to the RMA. These are assets that you guys have in territory on your end as well, right? So D6s, D8s, we've done a bunch of those, some of the graders. So more and more of these are coming in, 14s, 16s, 140s, 160s, starting to do more and more of those. Wheel loaders all the way from 938s to 980s. More and more waste compactors, we're seeing more and more of these quotes come in, and then some of the tracked loaders as well, right? So 963s, 973s are becoming more and more of a common model for us to rebuild. I actually think all of these are so far in 2021 on the tracked loader piece. So one thing I just wanted to share on the finning side of things is we are shifting towards what we call a RRR network model, where we have facilities dedicated to major overhauls and rebuilds across our network. And so we have 6 of these facilities really across the network. And really what it means is we're better positioned to rebuild equipment throughout the entire year. What's great about this is, you know, even when you look at oftentimes for RMA customers that busy during the summer months, right? We have solutions to help ensure that we're rebuilding machines and equipment in a timely manner, or we have a rental machine to support the process, right? So sometimes what that means is, you know, we have that rental available. Maybe we have a machine sitting on the fence, right? That's already been rebuilt that can be subbed in there as well. We also have, you know, exchange solutions with a component perspective that allows us to swap machines in and out of the shop very quickly, especially in those summer months. So what does that rebuild timeline look like? And for the purposes of this, I'm going to talk about this as if it was a CPT or CPT plus type approach. So this is a, you know, a traditional view as to what we would expect to see. So that first stage of this, that decision to explore rebuilding a machine, oftentimes we see that take anywhere from 1 to 6 months, right? It's part of that budget gathering exercise. It's looking, hey, what should we do? What do we need to do on the machine? Where's that optimal timing point to do that? Once that piece has been done, we look at obviously connecting with us at Finning, where we're able to provide a high level estimate, maybe start to have that budgetary discussion. And then really the next piece of that would be, okay, you're more interested in doing a rebuild. Let's look at doing an inspection on the machine, perhaps, producing a more formal quote based on the machine condition as well. We expect that piece takes, you know, anywhere from 2 to 4 weeks, depending on, you know, when we can get out for an inspection, how long that, you know, consideration and conversation piece to take as well. So then you have kind of that, you know, rebuild decisions made. What happens then? The machine enters the shop, wash, disassembly, you know, the beginning stages of that rebuild start to take place. And then we'll essentially get to that mid-job level. And so what we see is that part of the process will often take, you know, somewhere in the 3 to 4 week range to get to that mid-job level. And again, just depends a little bit on the machine. And then we'll get to that mid-job. We'll talk about, hey, maybe these things came up. Maybe it was higher, lower than we thought, just based on the condition of the machine. Maybe there were also some things we looked at doing that, you know, additionals that made sense to do, right? So we have that conversation and then we finish out the job. So obviously job completion, reassembly, we see that taking usually 2 to 5 weeks, again, depending on the machine size and what's being done to it. And then finally you have, you know, machine delivery, invoicing, and then that warranty enrollment as well. So right now, what I'll share is a couple of the programs that we have in market, and then a couple of the things we're working on the Finning side as well. Right now, we have these better than new programs, which some of which apply directly, obviously, to machines and territory. These are funded in part by CAT, and basically what we see on the screen there is, 140s, 966s, 972s, D6s, D8s, and 980s are captured within this program. There are more and more of these machines actually coming into the program as the year goes on, and it's a really neat one from Caterpillar. It's basically, if you rebuild your machine, you're getting a couple things. You're getting EPP, you're getting a CVA included with that. So that's the, parts maintenance kits. Those are coming to you. You'll get performance upgrades, you'll get safety upgrades, and some of the other pieces there as well, right? So there's lots of great factors to these specific better than new programs. And we expect by the end of the year, we'll add about another 10 machines to this list as well. So one of the things I'm specifically working on for RMA customers is do not exceed pricing, right? And so, as part of our rebuild efforts, we've heard from customers in the RMA that it would be great if we could get to that point where the price we have, committed to at the start is the one that, ends the job or comes very close to ending the job at as well, right? We understand that having that conversation with council, if the rebuild has to go back and there's something additional that comes up, that maybe we hadn't scoped out or hadn't noticed initially, either yourselves or ourselves, that's a difficult conversation to have, right? So this is something we're working on developing. What this program means is we'll give you essentially that guaranteed price for your machine rebuild, and we want to make sure that we're sticking with that guaranteed price. What I will say right now is, because every machine is different, I can't say that it's going to be X%, right? That guaranteed number might change a little bit just based on what we're seeing with the machine. We hope to roll out a bit more of a program around this, but basically we would ask to do a machine inspection. We want to confirm condition of the machine. We want to look at some of those elements and make sure, there's, those level 3 parts, for example, I mentioned at the start of the call. We don't see major failures happening in some of the components, right? Those are typically the things that increase the cost a bunch. And we want to make sure, if we're going with these guaranteed prices, we're really de-risking it for yourselves and for ourselves as well. And then the last piece here is really, there's a lot of programs that come out from Caterpillar. I mentioned a couple slides ago. And really what I want to press today is, we had a specific program for RMA customers last year, and we didn't see a ton of uptake on it, right? Specific to some models, right? And so we want to approach it a little bit differently this year. And we want programming focused on the elements that are most important to you. So it's about building those customized plans. And what I've heard in my conversations with some of you is guaranteed pricing. That's a big one, right? And so we're working on a bit of a platform there. Warranty terms, extended warranty terms, right? Those are big elements as well. Those help de-risk on the back end of rebuilds. Guaranteed turnaround times, right? Making sure that we can get the asset back to you in a specific time. Or, like I mentioned before, rental machines to help cover that downtime when it comes up, right? And then, the last two there is really aggressive pricing relative to new machine costs, right? So how do we make sure we're staying aggressive relative to, whether it's CAT equipment or some of our competitors as well? We want those rebuilds to be aggressive. We know that we're a little bit different in the sense that you can rebuild almost all CAT equipment. It's something that makes CAT equipment great, really makes us stand out, but that still means that rebuild price needs to be really aggressive for it to make sense for you. So we have some things in place for that as well. And then finally is that different tiers of offering piece, right? So, it's starting with, certified, it's going down through dealer rebuilds, it's making sure we have solutions on a component level, even going all the way down to used parts. Oftentimes we'll even have what we call used parts that have never been used before, right? It's just the categorization. Once they've been taken out of a machine, they're considered used, right? And they could have been taken out of a new machine. So there's a bunch of different levels there. And really what we want to do is we want to build a solution that works for you, right? It's impossible to put a campaign or a program out there that makes everybody happy, right? We know that. What we want to be able to do with you is build that customized approach that focuses in on those things that are most important to you in the rebuild. Maybe it's guaranteed pricing and turnaround times, or maybe it's having that maximized warranty term. But really what we want to do is have that conversation to make sure that we have that customized approach. And that is it for me.
Awesome. Thank you so much, Jesse. That was a great presentation. And, we look forward to talking more with the members about rebuilds and, what that looks like for their specific municipalities. So on that note, thank you. And thank you everybody for signing on today.